NEC Section 700.15 mandates that emergency lighting systems be supplied by a separate circuit or circuits. This requirement is in place to ensure the reliability of emergency lighting during a power outage. The intent is that emergency lighting fixtures, which are designed to provide illumination for safe egress from a building, will function independently of the normal lighting system. If a single circuit were used for both normal and emergency lighting, a failure in the normal lighting system could also disable the emergency lighting, defeating its purpose. The separate circuit requirement means that the emergency lighting must be wired on a circuit that is dedicated solely to those fixtures. This circuit must originate from a reliable power source, typically a generator or battery backup system. The power source must be capable of automatically providing power to the emergency lighting system within a specified time frame after a power interruption as defined by the code. The specific time frame can vary depending on the application. It's important to understand the scope of NEC Section 700.15. Firstly, it specifically applies to emergency lighting systems. These are defined as lighting systems that are designed to provide illumination essential to safety of human life in the event of failure of the normal lighting. Secondly, the requirement for a separate circuit applies to the emergency lighting system as a whole, not necessarily to each individual emergency lighting fixture. While the code does not explicitly require each emergency light to have its own dedicated circuit, it is permissible and often good practice to do so. This can improve the overall reliability of the system, because a fault in one fixture's circuit will not affect the operation of other emergency lights. The interpretation of NEC Section 700.15 is crucial for proper electrical installation. When installers run a single circuit for all fixtures and tap an unswitched hot wire for the battery backup units, they are in direct violation of the code. This practice undermines the integrity of the emergency lighting system and creates a potential safety hazard. It's important to also remember that an unswitched hot wire is permissible, but not in place of a completely separate circuit. The authority having jurisdiction, or OUTAGE, is responsible for enforcing the NEC and other local electrical codes. If you observe an electrical installation that you believe is in violation of the code, it is your responsibility to report it to the AHJ. The AHJ will investigate the situation and take appropriate action to correct the violation. Here are some additional points to consider regarding emergency lighting circuits. 1. The overcurrent protection devices such as circuit breakers or fuses for emergency lighting circuits must be selectively coordinated with the overcurrent protection devices for the normal lighting circuits. This means that if a fault occurs on a normal lighting circuit, only the overcurrent protection device for that circuit should trip. The overcurrent protection device for the emergency lighting circuit should not trip, ensuring that the emergency lighting remains operational. 2. Emergency lighting circuits must be clearly identified. This can be done by labeling the circuit breaker or fuse panel with the words emergency lighting or by using a color-coded wiring system. 3. Regular testing and maintenance of emergency lighting systems is essential to ensure their proper operation. The NEC requires that emergency lighting systems be tested at least annually and that any necessary repairs be made promptly. Emergency lighting systems often incorporate automatic transfer switches, or ATSs, which automatically switch the load from the normal power source to the emergency power source in the event of a power failure. The ATS must be properly sized and installed to ensure that it can handle the load of the emergency lighting system. Furthermore, emergency lighting is often used in conjunction with exit signs to guide occupants to safety during an emergency. Exit signs must be illuminated at all times, and they must be clearly visible from all directions. The NEC contains specific requirements for the size, color, and illumination of exit signs. In buildings with complex layouts or high occupancy, emergency lighting may be supplemented by emergency power systems, or EPSs. These systems provide backup power for a variety of critical loads, including emergency lighting, fire pumps, and communication systems. EPS can be powered by generators, batteries, or uninterruptible power supplies, or UPSs. The design and installation of emergency lighting systems is a complex process that requires careful attention to detail. Electrical engineers, contractors, and inspectors must work together to ensure that these systems are installed in accordance with the NEC and other applicable codes and standards. Let's consider several scenarios that highlight the importance of separate circuits for emergency lighting. Scenario 1 involves a commercial office building. A fire breaks out in the main electrical room, causing a widespread power outage. If the emergency lighting is on the same circuit as the normal lighting, it will also fail, leaving occupants in darkness and hindering their ability to evacuate safely. With a separate circuit and battery backup, the emergency lights activate, illuminating exit paths and allowing for orderly evacuation. Scenario 2 features a hospital setting. A severe storm causes a power surge that trips the main circuit breaker. In this critical environment, emergency lighting is essential for maintaining patient care and safety. If the emergency lights are tied to the same circuit as the general lighting, they will go out, potentially jeopardizing lives. A separate generator-backed circuit ensures that essential medical procedures can continue without interruption. Scenario 3 involves a large retail store. A faulty electrical panel causes a localized power outage. If the emergency lights are not on a dedicated circuit, the outage could plunge large sections of the store into darkness, causing panic and making it difficult for shoppers to find their way out. With a separate circuit, the emergency lights provide directional guidance and prevent accidents. The importance of adhering to NEC 700.15 cannot be overstated. Failure to comply with this requirement can have serious consequences, including loss of life. It is crucial that electrical professionals are properly trained and knowledgeable about the NEC and that they follow its requirements meticulously. In summary, always ensure that emergency lighting systems are wired on separate circuits as mandated by NEC 700.15. Use reliable power sources like generators or battery backups. Ensure selective coordination of overcurrent protection devices. Clearly identify emergency lighting circuits. Regularly test and maintain emergency lighting systems. Adhere to all applicable codes and standards. Report any suspected violations to the appropriate authorities.